Okay, I want to talk about uh, the benefits of using a carburetor jetting calculator. First of all, it's an Excel spreadsheet and it is very easy to use. Let me show you. If you have Excel, when you download or record um, a spreadsheet like one that's sent to you on the email, you just find its location. In this case, it's in the downloads folder, and double click on it and it will open Excel for you with that spreadsheet ready to go. Okay, and then what is the spreadsheet? If you look, I just clicked on that cell right there, and inside that cell is this formula. So it's a combination of data entry cells where you just enter in information, and then the different other cells make use of that information and they process it in different ways. In this case, the final result of all the information about the carburetor ends up in a graph over here. And what this graph is this right here is the slide opening from 1/8, which is basically closed throttle, to wide open throttle. And this axis right here is the jetting of the calculator. Uh, above 1.0 is rich and below 1.0 is lean. So if you have jetting of 1.2, that means it's 20% rich, or 0.8 means 20% lean. This blue graph is the actual jetting of the carburetor. If it were from here all the way to right here, that would be a perfectly linear response of the carburetor to the slide opening. But as you see, it's a little bit richer at the beginning portions of the slide opening. And that's what Jennings, back whatever that was, 25 years ago, said is common. And so a comparison between what is actually graphed from these settings that results in this blue graph right here and the ideal, the difference between those two is the red graph. So in this case, it's a perfectly straight line because I fudged the numbers just a little bit. You can see that minus 0.008 right there, and the minus 0.003, plus 0.01. So I fudged the numbers to get that perfectly straight line, just for illustration purposes. This is the results of changing the values of the jets and the slide and the needle, and seeing how the jetting changes throughout the whole range of the slide opening. And this is the only realistic representation of what happens on the internet. All the others are just people's ideas of what's happening. Let's show this slide. Let's double that number so we can, that's the slide cutaway number. Just for illustration purposes, you can see it affects mostly at the beginning, but it affects all the way up to 7/8 slide. Very interesting. Okay, let's increase the main jet 10% and see if it just affects the wide open throttle. Oh, looky there. Wide open throttle, it affected 7%, but at closed throttle, it affected it 2%. And this is what some people don't understand. When that slide is closed, there's still some opening there. It's closed slide is not closed, it's like 1/8 open. And so there's still suction here on the needle, in the needle jet. So you're still getting some some air or gas through that. Let me show you the actual numbers. So the area right here of the closed jet, which is basically the space between the needle jet, or the jet of the needle, and the needle itself, the straight portion of the needle. In this case, the area is 0.65. Okay, and the area of the idle jet is only 0.38. So you see, you've got almost twice the area on the needle jet than you do in the idle jet. The only reason this doesn't have more effect is because that slide closed position, or 1/8 slide open, there's reduced suction there. But right under the front of the slide, where most of the idle air screw openings are, there's plenty of there's more suction. Okay, so now I want to show you the effect of the needle taper. Okay, right now we've got a taper degree of basically 0.8 degrees. Okay, let's change that, and we have reduced that taper degrees to a little bit less than 0.5, and that lowered angle has caused a lean condition starting at 1/4 throttle. Okay, and if we go in the opposite direction, you'll see the opposite effect. Yeah, from perfect jetting, look at how it changed, and it's pretty much level from about 5/8 throttle on. Okay, so that's the effect of the needle angle, and that's with the single taper needle and a needle jet shroud. This is the shroud. This catches more of the suction wave coming from the engine to pull up more mixture. And with more velocity of air, it has more of an effect of doing that. So let me show you a picture of it. This is the needle shroud. Okay, so yeah, relatively easy to use. On this calculator, if you look at the bottom left, you've got all these tabs out here. I've got 5 tabs. The very last one says velocity. If you click on it, you come to the velocity page, which calculates the air velocity through the carburetor. So with the 55cc engine, a transfer duration of 122, and this doesn't make a lot of difference. I'm going to put a 126 and see what the engine volume efficiency changes to be. It changes by 1%. Big deal. Okay. So that's not essential. If you just leave 124 there, that's okay. 8,000 RPM, 18mm carb. It gives me 22.7 carb flow velocity at 345 engine volume liters per minute intake. So we've got a tab for the Mikuni VM and TM carbs, the Mikuni TMS and TMX, and that's not the new ones with the PowerJet. The PowerJet throws everything off, so I'm not even including that. If you want to disable the PowerJet, then yeah, this will work on the TMX. But the old style does not have the PowerJet. Keyhine, which is the PWK, PE, and PJ, and most all the Del Ortos except for the SHA. So yeah, on all of these you just enter in the the jetting data. On the Keyhine and the Del Orto, you have to manually enter in the information, which is not much on the Keyhine. You just enter in the taper degrees and the taper minutes. And a minute is basically a fraction of a degree divided by 60. So half a degree is 30 minutes, because 30 divided by 60 is 1/2. But it will look up the it will give you right here what the degrees and the minutes are if you give the needle ID code in these 3 sections right here. But then you have to manually enter those right here, along with the needle diameter, which is right here, which on the charts that have the information, well, it's on my website. Let me show you. On the Keyhine page, these charts right here. So it has 3 letters. The first letter is this section right here, which is the taper degrees and minutes. The second is the L1 length, which is right here. And the third is the diameter of the straight portion of the needle, which is the portion above the taper. You see, each letter gives you different diameter, and that diameter is what goes right here. Then you've got the needle jet hole diameter. On my site, it tells you right here. It's either 2.9 or 2.6, depending upon your model. And on Mikuni, when you look up what is basically supplied with Mikunis, right here, the letter and the number, such as N8 for a VM24, you enter that here, and it decodes that and gives you the diameter right here. On Del Orto, the needle jet ID begins with 3 numbers, and you just divide those 3 numbers by 100, and that gives you the needle jet hole diameter, which it does it for you automatically. Then you got the main jet number right here, and then these the slide cutaway, elevation, percent ethanol, and the gasoline, which, if you don't know, and it doesn't say on the gas pump, you can buy an ethanol percentage tester from Amazon for like $10. Outside temperature, percent humidity, fuel oil ratio. So it's great. You know, you enter the required data, which for the Del Orto, it also requires the needle data, which you can get from my site right here. It tells all the different needles for the different carbs and what the data is, A, B, C, D, E diameters, which are on my spreadsheet right here. That's where they go. Why, oh why would you want to add this complexity to your life? Well, for one, it's not really that complex. The complexity is all behind the curtain. I deal with the complexity. You deal with the simplicity. You enter the data. You see what happens to the graph, and you make the corrections to give you a nice straight line. And so you're virtually making all the changes you need, and then when you're finished, you're saying, oh, okay, well, this is the number slide cutaway I need, this is the main jet I need, this is the needle I need, and this is the pilot jet that I need. And then you go to Jets R Us or one of the other companies and just buy what you need. Okay, you're gonna buy one of each. It's like $6 for one, the idle jet, $7 for the main jet. Where's the needle? The needle is $7, yeah. Okay, $6.49. I think it's idle jet. Yeah, that's idle jet. But if you don't have a calculator, what are you doing? You're gonna say, well, it feels like it's rich, so I'm gonna go a couple sizes, buy the next 2 sizes lower on the idle jet, next 2 sizes lower on the main jet. My buddy says a different slide would work better. I don't know. Other buddy says a different needle work. I don't know. Maybe I'll get the needle. Maybe I get the slide. And voila, look, we've got a sum total here of $60. A couple pilots, a couple mains, a couple needles, and a slide. And a slide for a VM is cheap. It's almost $21. Look what it is for a Keyhine PWK, $73. So it saves you a lot of money. It saves you a lot of headache. It saves you a lot of trial and error. So the time and the effort you save from actual real life trial and error testing is much more than the extra time and effort it's going to take to learn how to use this program to find out what exactly you need. It's a no-brainer. You know, I don't care if you've never ever used Excel. It's just as easy as I said. You just click on the file, it opens up, you enter into the numbers and the IDs into the light blue boxes. The dark blue tells you what is expected to be entered there, and you look at the graph, and then you can look at this, which is also on my website, to get an idea of how much each affects, and you can know from there what to change. Like, you want to change it a 1/8 slide. Well, the needle angle is going to affect that. The main jet has minimal effect on that, so you want to look at the slide cutaway and the idle jet. It's just that easy. This is my website. This is the address right here, the section that lists the calculators I sell. And if you click right here, it says how to buy. It will give you the links you need to go to where you can pay with PayPal. And if you don't have PayPal and you don't want to get PayPal, you can just send me an email, which is also on my website. And I will tell you how much to send, and you can send it by Western Union. If you're in the States, you can go to the service desk at Walmart, and they will help you take care of a Western Union money transfer. These are the calculators I sell. Fuel oil ratio calculator, which is a fantastic calculator. Takes all the guesswork at what ratio to use for your fuel oil ratio. Boost bottle calculator, crank balance calculator. It's the only calculator in the world that every 15 degrees takes every single force and vector into consideration, and gives you a graph and shows you what is happening and what you need to do. Jetting calculator, it's only $20. I forgot to tell you that. You easily save $40 by buying it, easily. Porting calculator, squish velocity calculator, and my expansion chamber calculator, which is a true return wave simulators. There's others on the market that have fake return wave simulators. This is the real deal. Okay, my friends, thank you for watching, and we'll talk to you later.